So a quick check to see how well you remember the layers we covered in the previous video. A quick recap to refresh your memory. We talked about the required functionality in computer networks and how this functionality is organized in the form of layers. We covered the 5 layers of the Internet Protocol stack. In this video, we will look at how the layers interact with each other. A layer, more precisely a protocol that belongs to a given layer, provides certain functionality. For example, we are talking about the transport protocol. TCP is a protocol that provides reliability. Typically, a higher layer protocol, for example, email process, makes use of the services offered by this protocol to achieve reliability. And the way these both are going to interact with each other is through a service interface that this particular protocol provides. There is another interface called the peer interface. The peer interface is used to interact with the counterpart that is typically implemented on some other node. For example, the transport protocol that is running on node 1 interacts with the transport protocol that is running on node 2 through the peer interface. Now, why do we need a peer interface? Let me explain it through an example. Suppose the email process wants to send a message M reliably, so it passes it on to TCP. Do you think if TCP just takes this message and stamps a big "don't you dare mess with me," you think it's going to solve the problem? No, that's not how things work, so it needs to do something better. So how do you think this is handled in the postal system? That's right, you need return receipt. Basically, you need someone at the other end, basically the destination, to acknowledge the receipt of the message. So for this, the peer on the other end has to send back a message that says I have received this message or not. If it says I didn't receive the message, the transport protocol, the TCP, can resend the message. So that is why you need, for executing a given functionality, both sides, both endpoints to be involved in the process. So implementation of the service interface is rather straightforward. Both the layers reside on the same machine. You can just use up calls and down calls. But how will these two protocols that are on two different machines communicate? In other words, how are you going to provide the interface between these two protocols that are on two different machines? So all this interaction between the layers is to facilitate transfer of a message. So to achieve peer-to-peer communication, what we do is we take the message and add on additional information to it. For example, layer n+1 has generated a message M which gets to layer n. So layer n is going to add some additional information. This is called a header, and the one it adds at the end is called a trailer. Trailers are not necessary, but in some cases they get added. This information is only for its counterpart at the other end. This information is of no relevance to the layer above or the layer below. This information is mainly for its counterpart. And this, it gets passed on to the layer below it, which adds on its own information. And when this message finally reaches the other end, so this layer n-1 will read this blue information because that is what it is pertinent to it. This information is not pertinent to layer n, thereby when it is passing it up, it removes this information. So this is called the decapsulation part of it. And similarly, when layer n processes it, it is going to remove the information that is pertinent to it and passes it up. So as the message comes down, it gets encapsulated with more and more headers, and as it goes up, it gets decapsulated. So finally, the layer n+1 gets whatever message is intended for it. So let me explain it through the Internet Protocol stack. So for example, the email application has generated a message M and it passes it to the transport layer. So if this is the TCP protocol, it adds its own header. One of the things that could be inside this header is a sequence number, so that the other end can acknowledge that it received this message corresponding to this sequence number successfully. And it passes it to the network layer. Network layer adds its own header. One of the fields that could be inside here is the address of the destination. In this case, it will be host 2 address, because that is where this packet or message is destined to. And it passes it to the link layer, and link layer knows that to reach there it has to go through node 1, so it adds its own headers, and maybe the destination here will be the node 1 because that's where it has to go. And then it goes to the physical layer, which will add its own headers. Now as this message comes here, this is, by the way, over an actual physical link. This physical layer will remove its physical header, passes it up, and then this will examine its link layer, it will remove it and passes it up. Now this intermediate node 1 is a router which will decide where this message has to go. So remember that there is no transport or application layer, because this is a router, and its job is to just decide where to route this message. It really doesn't need to implement the transport or the application layer protocol. Now this router will decide that in order to reach host 2, this host, it needs to go to intermediate node 2. For all you care, this router may be connected with another intermediate node 3, node 4, and so on and so forth, but it decided that this message has to go through node 2. So thereby it will pass this message down, and this is now going to carry a destination address that corresponds to node 2. And then it will pass it, and then again it goes up, it comes down, and finally at end host 2, this message goes up, and as it goes up, each of these headers are removed, and finally the message is delivered to the email process that is running on end host 2. So this is how the message flows through the protocol, and this is how the peers also communicate, basically by piggybacking control information on the messages. So they communicate with each other in this particular fashion. So another point to note here is that this is a physical connection. So when I say the transport layers interact with each other or communicate with each other, this communication is over a logical connection. In other words, they are not directly connected with each other. For this communication to happen, the message actually had traveled like this, and then came down, it traveled up again, it came down, and then it traveled all the way up here. So this communication between the transport layers is over a logical connection and not a physical connection. Another and the last point in this video, remember I said that there are many protocols at a given layer. Now suppose the transport layer, the TCP got a message M. How does it know that this message is for the email process or the web process or the telnet process? How do you think it is able to pass the message to the right process? Another buzzword, multiplexing and demultiplexing. So this happens through certain fields within the headers. For example, the link layer header will have a field called the frame type, which specifies which among the higher layer protocols should this frame be passed. So if it had a type field that corresponds to IP, that message gets passed on to IP. If it has a frame type corresponds to ICMP, it will pass the message to ICMP. Similarly, the network layer header will have a field called protocol, which specifies whether that message has to be passed to the TCP protocol or the UDP protocol. Similarly, the transport layer header will have a field called the port number, which specifies which of the application processes this message has to get passed on. So this multiplexing demultiplexing key is embedded in the headers to facilitate passing the message to the right process or protocol.
So here is a summary of what we have learned in this video. So layers implement certain functionality, basically protocols, and to execute this functionality, layers need to communicate. There are two interfaces you need for this. One is the service interface, which permits a layer to make use of the services of the other layer within the same node. And peer interface facilitates communication across two peer layers on two different nodes, and this is achieved through encapsulation and decapsulation. We also saw that it is important that a message gets passed on to the right process or protocol, and this can be achieved via the demultiplexing key, which is also embedded within the headers. Now we are ready to look at each layer individually.